The next topic that we're going to cover in this section is off a little bit from what we've been doing, which has been looking at graphs. We're going to look at something called the difference quotient. This is a ratio that represents a rate of change. And the definition of the difference quotient is f of x plus h minus f of x over h as long as h does not equal 0. This should look a little bit like the equation for slope, and it is derived from that. Let me give you an example. So if I have a function and I draw a graph, change color here, mix it up a little bit, and I want to find the difference quotient, I can look at 2 points on the graph. X, which in this case would be here, and then I'm going to pick another point, x plus h. As long as h isn't 0, which would mean I'd be taking a slope from a point to itself, I can find the difference quotient. And it really is just the slope. In function notation, the ordered pair at the first point would be x, comma, f of x. In function notation, the point here would be x plus h, that's my new x value, and f of x plus h, which would be the corresponding y. You can see that if I take the slope of these 2 points, I'm going to have f of x plus h minus f of x, that's y minus y, over my x values, x plus h minus x, and I hope you can see that this denominator then will just simplify to h, and that's the difference quotient. And again, we have to make sure that h isn't 0, because if h is 0 and I have x and x plus h, I'm really just looking at the same point, x and x. So that's our difference quotient. We're going to be using it a little bit this year. We're going to be looking at it particularly towards the end of the year, but they've thrown it in here because we're talking about functions, and a slope of a function is part of that. So let me give you an example. We're going to find the difference quotient for this first equation. Actually, let's back up, and I'm going to do a difference quotient for a very, very simple equation. I'm going to erase this ink, and let's do a very simple one on this page. Let's say we have y, we'll use our f of x again, sorry. F of x equals 2x plus 1. To find the difference quotient, which is, again, f of x plus h minus f of x over h, I have to first find out what f of x plus h is. Hopefully you remember how to do this. Let me give you some quick aside notes. You don't have to put this in your notes if you don't want to. If this is our function, how would we find f of 3? Well, we plug in 3 for x. Oops, sorry. So 2 times 3 plus 1 would give us 7. To find f of b, we would plug in b for x. So to find f of x plus h, and I'll do that down here now, I'm simply going to plug x plus h in place of x. I can expand this a little bit, and I get 2x plus 2h plus 1. That is going to be substituted for f of x plus h. 2x plus 2h plus 1. So that's the first part. Now I want to subtract f of x. Well, f of x was defined here as 2x plus 1. And all of that's going to be divided by h. So distributing the negative sign, I'm going to get 2x plus 2h plus 1 minus 2x minus 1 over h. And if I simplify the numerator, 2x minus 2x, 1 minus 1, you can see that I have 2h over h, which simply equals 2. So the difference quotient for this function is 2. Now in this case I ended up with a simple value. In some cases we may end up with an equation. So let's do a more complicated one now. So I'm just going to deal with the one on the left. We're going to work that together, and then I'll give you a minute to try the one on the right. So the first thing I need to do is to write down the difference quotient so that I can remember my formula. And I'm going to do that with this equation. So what is f of x plus h? Well, again, I've got to plug in my x plus h in place of x, every place I see it, and then I'm going to simplify. So that's 2 times. Remember, to get x plus h squared, I need to FOIL it. X squared plus 2xh plus h squared. Distribute the negative, and plus 3. My final step would be to distribute the 2, and then to see if I can simplify anything. It doesn't look like I can. So this entire expression is my value for f of x plus h. So, working down here, I'm going to repeat all of this for my f of x plus h, 2x squared plus 4xh plus 2h squared minus x minus h plus 3. From that, I need to subtract my f of x. That's this value at the beginning, so I'm going to subtract my 2x squared minus x plus 3, and that's all divided by h. So now I need to clean up the top. If I distribute over here, and I'm going to change my ink colors for a minute, if I distribute this negative, I'm going to get negative plus minus. So now I can clean up the top. 2x squared minus 2x squared. 4xh plus 2h squared. Negative x plus x minus h, and the 3's cancel as well, all divided by h. And if you remember your algebra, as I simplify this, I can divide each term by h. This is the same as 4xh over h, 2h squared over h over h, and I will get 4x plus 2h minus 1. Remember, when those h's cancel, I have a 1. So this is the difference quotient for this equation that we started with up here. It's a lot of work. It's not difficult. It's just time consuming and paper consuming. So at this point I'm going to erase, so if you need to pause, please do that. And I would now like you to try to find the difference quotient for this equation on your own. Remember, your first step is to find your f of x plus h so that you can plug it into the difference quotient. So please pause the video and do this for yourself now. Okay, f of x plus h is negative 3 times x plus h squared plus 2 times x plus h, which is negative 3 times x squared plus 2xh plus h squared plus 2x plus 2h. So I'm going to get negative 3x squared, minus 6xh minus 3h squared plus 2x plus 2h. That is my expression for f of x plus h. Putting this into my difference quotient, I have negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus my original f of x all over h. Again, if I distribute the negative sign, This becomes positive, this becomes negative, and I can cancel. Negative 3x squared, positive 3x squared, positive 2x minus 2x, and I'm left with negative 6xh minus 3h squared plus 2h over h, and if I cancel an h from each term, negative 6x minus 3h plus 2, and that's my difference quotient. I wanted you to note one thing before we move on. When you're at this step, all of the terms that do not have an h should cancel. You should be left with only those terms that have an h, so that when we put it over h, every single one will be able to cancel at least one of the h's in the term. So that's the difference quotient. If you need to go back, please feel free to pause, go back and look again. This is an important concept, and as I said again, it takes a bit of paper and it's a little tedious, but once we get that f of x plus h and start to do our substitution, the math itself is not terribly complex.